Hello my friends, and welcome back. In today's live programming video, we're going to be doing some work on Komorebi. Komorebi is a tiling window manager for Windows written in the Rust programming language. Today, I wanted to take a look at something that came up in the issues that I have also noticed, but I have kind of lived with until now. So I think it's this one. Tile sizes are incorrect with different window scaling. So my setup is, I don't have 3 monitors, I have 2 monitors. And if I can just get my display settings up. So I have a vertical monitor here, monitor 2. And the DPI, the scale on this is 125%. And the scale on this one right now is 175% so that you can see what's on the screen. Usually it's at 100%, but you know, for the purposes of this live programming and hopefully live fixing video, this bug will be reproducible. So Alan Manning says, if I have my monitor with display scaling on, the windows do not have the correct size when switching between monitors. So I have Spotify open now on my vertical monitor. I'm going to move it. And it worked. So maybe it's only a bug that happens. Wait, let me set my DPI back to 100. So, I mean, I guess first of all, we should validate when this behavior occurs. Right, so here we go. So that is a very important piece of information. So this error only occurs when a window is moved from a monitor that has a higher scaling percentage to a lower scaling percentage. Alright, let's set this back to 175 so that y'all can see what is going on. And yeah, we're gonna take a look through what guards we have in place in the code. We're gonna do some debug logging, and yeah, hopefully we can put this bug to rest. Yeah, so let's see where to start. So I have something with scaling. So let me think this through out loud, right? So we reproduce this bug when we call the Komorebi C move window. Or is it just move? Komorebi C move, right? So when we call the Komorebi C move command and we go from 125% scaling monitor to 100% scaling monitor, that's when we reproduce this. So I think we should go and dig into the code starting from when we handle the move message. So let's go to process command, move, is it move window? Yeah, that's the one. So when we get this socket message, we call move container in direction, which is a method on the window manager struct. So I already see comments. Alright, so we handle the unmanaged window behavior. We get the focused workspace. Removing this messes up the monitor container window index somewhere and results in the wrong window getting moved across the monitor boundary. Okay, that makes sense. And then we start moving container. So if there is nowhere to move on the current workspace, try to move it onto the monitor in that direction if there is one. So that is this case, none. If we don't have a target container index, we try and find a target monitor index. Okay, monitors have same scale factor. So this is gonna call an additional update because we're calling update here. So this calls an additional update. So I think this is a good place to make sure that this is doing what we think it is, right? So let's add a debug here. Not like that, like this. And we'll call it with A and B. Because... well, actually, let's debug the result type. Because it may be that this function is not being called correctly, right? So, why don't we get this over there, this over there, and we can go into Komorebi. And actually, why don't we build in here, right? Why don't we build in here? We'll do Komorebi C stop, and is it just run? No. I need to update this clearly. So let's update this because it should be now install. Oh my god. Install target Komorebi C, and then I think I've been doing cargo plus stable run bin Komorebi. Yeah, that is what I've been doing until now. Cool. So let's just run at info for now. So Komorebi C should already be up to date, so that was in fact a quick one. And now we recompile with our changes. And although we can't reproduce the bug when moving from a lower scale monitor to a higher scale monitor, we should still expect this to return false because the monitors do not have the same scale factor. So why don't I let's get this here. Monitors have same scale factor is false here. Okay. So let's set this to set DPI 100 and try that again. Sorry folks, I know this is going to be a little bit small, but that's really weird. That's really weird. So let's see if I can zoom in on this. So this actually changes, the value return changes. So if we look at this call here, this was when my primary monitor that these windows are being recorded on, when this was set to 175% scaling, monitors have same scale factor was false. When I moved Spotify back to the vertical monitor, which had a lower at 125%, so it had a lower scaling. This was true, and then after I changed the scaling on this primary monitor to 100%, and I moved Spotify from the vertical monitor 125% to this monitor 100%, this also returned true. That is not great, because I would really like for for this function, this Windows API call to be returning the same thing, right? When you, like, it shouldn't make a difference if the DPI is smaller or larger. It should just care that it's different. The Windows API strikes again. So let's see, what are we calling scale factor for monitor? So we're calling get scale factor for monitor. Let's get that up in the Win32 API, and let's read the docs. Gets the scale factor of a specific monitor. This function replaces get scale factor for device. We might have to go back to this. Oh, it's not supported. Alright, so we get a HMON, which is a handle to a monitor, and then we pass in the P scale, which is what we check at the end. Your code needs to handle the WinPos changed message in addition to the scale change event registered through register scale change event, because the app window can be moved between monitors. If the function call fails, this value points to a valid scale factor so that apps can opt to continue with incorrectly sized resources. So why don't we add some more debugging here? Yeah, so let's debug A and let's debug B, so we can see what this is like going in either direction. Well, this is definitely not what I was expecting. Definitely not what I was expecting at all. Why can't things be easy? Unfortunately, that is my takeaway. Nothing is easy when working with the Windows API. Alright, so we're gonna move over Spotify again. 140 to 100. Huh. It is not 140. Scale factor. Why are you saying it's 140, my friend? Because it is not 140%. It is 125% and 175%. What the hell? What the actual hell? Okay, let's try moving it back. So we got false, 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 false. We'll set this now to 100, and we'll try that again. Let's make this a little bit zoomed in. Cool. So, I mean, let's just get this up here. 100, 100, true, 100. What the hell? Why, return correct value? Why, Oh, this is frustrating as hell. Maybe there is a different function for this. Let's just switch this back to 175. So, alright, maybe I'm passing the wrong arguments. It's possible. It is possible. Maybe I'm calling it wrong. Right. So why don't we quickly debug this as well? And debug this. So that's A. That's B. And B is going to be monitors. Get origin monitor IDX. Alright, let's get that running. So frustrating. Alright, so we got that up. Oh my god, it's the whole goddamn... Okay. Yeah, that was not very clever of me. Let's just do an unwrap on these so that we can get the device IDs. I don't know why I do this to myself. I wonder if one day I'll just get so fed up, like there'll just be a massive breaking change, and I'll be so done, you know, I'll be so freaking done. I'll hand over the reins to somebody else. Give up my title of benevolent dictator for life. Okay, so we move that across. So the origin monitor was the Dell, which is the vertical. So I'm definitely giving the right. But then why is it saying that this is 100? This is clearly, my guy, this is clearly not 100. Like it says right here, it says 125%. Why are you like this? Why are you lying? Why are you lying to me, Windows? Why? Alright. Time to Google, I guess. Oh my god. So it's always returning okay. Win32 API get DPI for monitor. Oh, that's a thing. That's a thing. What is DPI type? Angular DPI, raw DPI. The value of the DPI along the x-axis. Hey, this is what's happening to me, is get scale factor for monitor when API returning incorrect scaling factor. I'm also calling this, I'm also calling all this stuff. Never returns the correct scale factor for anything other than 100% DPI. Get DPI for monitor also does not return the correct stuff. Alright, so get monitor real, get the real resolution. Oh god, this is... Oh my god. Into the flood again. Into the flood again. Alright, so we have to do a diff. It looks like we get the real monitor res, which we already have, by the way. We have that stored on the monitor struct. We have both. Let me see, what are we? So we have the size and the work area size. So I think enum just I mean, we'll see. Well, I get monitor info X, right? I get that anyway. It will return the real native resolution. All right, yeah. Get monitor scaling ratio. Get real DPI for monitor. Get DPI persist. Oh, but these are functions that this person has. So what are they doing differently here? They get the monitor info X. Dev mode. I know what dev mode is. Win32 dev mode. Gotta figure out how to use that in Rust. Enum display. Didn't we do something with this? Enum display settings. No, we didn't. Okay, so this is what we're gonna do, if I can figure out how to do it. So we'll call this pub fun monitor scaling ratio, and we'll take a H monitor. We'll take the raw thing as an eye size, and we will eventually return an F64, I think. It's probably going to be a result of F64. So let's just get that there. Sorry, Benquad. Need that screen real estate. So we are gonna get Windows API monitor info XW, perfect. H monitor, we'll wrap that. Let info. Okay, so we have monitor info. Next we need to get dev mode. So let's do this. Enum display settings. And what is this gonna return? This is gonna return dev mode W, I guess. And we're calling enum display settings W. Right. Actually, maybe we can just do all this here. Just as we are. SC device. I mode num enum display settings mode. Enum current settings. I think that's the one. Enum display settings mode. Awesome. And then we need to pass a dev mode. Let dev mode equals dev mode W default. And that's probably going to be mutable. And we are gonna take a mutable pointer to this, but I think we do have to set the DM size to standard mem size of dev mode W. I think that's how it works. Is that... Oh, that's kind of weird. Can I do a U16 from, actually, of that? U6... Oh, it doesn't let me. Whoa, is U16 deprecated? I had no idea. U16 from U size, standard mem size of dev mode W. Huh. I don't know why it was giving me that deprecation there. That was kind of weird, because this is a totally legal thing to do, and it's nice because... Oh, it doesn't even return a result. Sweet. I find this a bit more readable. So we'll do here standard pointer address of immutable dev mode. I think that's it. Let... Oh, we don't have to do anything to this because this is going to set the info on the dev mode struct that we have here. So we are going to return... We don't do returns. We don't do that here. We're going to do info.rc info.monitor rc-monitor.write minus info.rc monitor info rc-monitor.left, I'm assuming. Maybe if I get rid of that, have a bit more space. Divided by dev mode dm pels width. Add a safe cast to F64. Right. So now let's call this here instead. And we should be able to monitor scaling ratio, and then that still returns a bool. Alright, let's check it out. Oh, what did I do? Let's bring this out. Method not found for bool. Okay, that's one. Expected I32 found U32. Oh yeah, this we can get rid of course. Where are my changes? 826. Yo, what happened here? The trait can into... Oh, that needs to be a BCW stir. I'm not sure how I'm gonna do that. But this one we can do a cast as I32 maybe. Huh. From U size is not found? Then why the hell did you find it? Where is this coming from? I thought this was the standard. Oh, okay, that's regex automata. Right. So let's just delete that and just do as U16. One error at a time, my friends, one error at a time. Expected copy type found, reference type. So this needs to implement into param. Can I do this like this? Nope. It's already saying no. So I think we can do as mute pointer. Did it want mute pointer or did it just want as pointer? There we go. We have compilation. We have compilation. So move over Spotify, see what we got. This actually is not quite what I was expecting. So alright, I guess we're gonna get the real DPI value now. What is get DPI for system? Alright, this is a Windows function. We can use this magic numbers, why not? Alright, so we will okay, so this is gonna be a value. Let's call it X. Actually, let's not call it X. I hate it when people call values X and Y. I need real value names. So this is gonna be monitor scaling ratio. Monitor scaling ratio. Wait, did I do this right though? Monitor info right minus left. Oh, maybe I needed actually another thing here, another separator. Yeah, I think that might provide different results now. Do that little update. Cool. So now we move Spotify again. 1.0? That is not right. That is not right. Oh my god, man. What did I get wrong? Alright, so I got monitor info X. Right? I got dev mode, I set dev mode DM size, then I ran enum display settings. With this enum current set, like, is this what is, so let's debug also dev mode.dm size, not dev mode.dm size, but dm pels width and dev mode.dm pels height. Alright, let's try that. Just to make sure we're actually getting some stuff here. And that I am passing the correct pointer or whatever. Okay, so we're getting the right stuff here. Yeah. So we are getting values back. That is good. So we do get monitor info, and then we return. What is static cast float? Yeah, I don't think that's a big deal. All right, let's do it step by step. Right, we're gonna do this. Monitor info, right? So we got that first bit. And then we are gonna divide that by dev mode.dm pels width what X is this, and let's just run bacon so that we can fix things on the fly. Cannot divide I32 by U32, so we'll do this as I32. So maybe Rust static cast. C++. Unauthorized. Lovely. What is a static? We can just ask, what is the Rust equivalent of static cast? Size.try into. Okay, let's try that. So we'll say this is going to be an F let's do F32. Since we have I32, let's do F32. And let's do try into. Then we gotta do the whole thing here, right? And then we're gonna try into Rust dividing two I32s. Integer division. So why don't we, as F32, just make everything as F32. As F32. Yeah, what about that? Cool. And we'll say then this returns then F32. Okay, good. Still giving me 1.0, which ain't great. Maybe the Stack Overflow dude was wrong. I mean, let's try this. Let's try this, I guess. Let system DPI. Oh wait, no, that's gonna be here. Let system DPI equals unsafe, get DPI for system. So system DPI divided by 96.0 divided by monitor scaling ratio. Let final so frustrating. Oh, that's a reserved. There's F32. Alright, let's see if this gives us a different value. Hey, not bad. Alright, so we got 1.75, but we got 1.75 for both. Why do we have 1.75 for both? Like something... I feel like I'm very close. I feel like I'm very close. I'm just I'm being silly somewhere. So... I mean... So A ratio, B ratio. So I'm doing some shadowing here that I'm not too keen on, but this also now means that I can do this. And we can validate if we have different HWNDs. A HWND B. Oh, it's a H monitor. It's not a HWND. It is a H monitor. We should do H monitor A, H monitor B, and then this is ratio A, and this is ratio B. Okay, there goes nothing. Oh wait, I didn't. God damn it. Why am I like this? Alright, so we want to actually make sure that we're getting different H monitors past here as well. Just debug, debug, debug all the way down. Okay. H monitor A and B is different. I don't get it. Why is the final DPI for them both the same? So we're definitely getting different H monitors. We don't need that one. Monitor scaling ratio. Okay. So... I also want to debug this, if it's debuggable. What is the SZ device? So it gets cold ones here, that gets... I mean, they're different devices. If you run the function on the second monitor, let me read this again. Okay, so... So let's separate these by H monitor in the output. Don't... Hey, why the... Oh, I'm not returning final DPI. That would help. That would help. Alright. Let's try this again. So for this H monitor we have that. For this H monitor we also have that. But you see this width is different. And so because the width here is different, I expect a different result. Which means I also want to see what is info.monitor.info.rc monitor.write and what is left. So let's clean up these debugs a little bit. Yeah, we know that these are different. It may be that might just be that we're missing something very, very simple. Oh. Right. So, although we're not calling real, I think I think I know what happened. This code, even though it's calling get monitor info, it's expecting these values to be the updated values from dev mode. I think. Let's validate that. Oh, but wait, that won't work. What am I thinking? So we're doing right minus left. Yeah, right minus left. So here we're doing 6,000 minus 3840. And then we're doing 3840 minus none. So why don't we try this, eh? So we're doing 6,000. Or when we start with this monitor, right? So we're doing 3840 minus 0 divided by 3840, which gives 1, which is not right. This will give you a ratio of the real resolution relative. Maybe there's a different way to do this. So that's all that debug, but instead of that, oh, come on, dude. Maybe we can do this a little bit higher up even. No. Because we need to compare them relatively. We do need to compare them relatively. You run this function for the second monitor. I am missing something here. I am clearly missing something here. Let's check out some others. This one seems a lot nicer. Monitor from point. Okay, we got the monitor. Get DPI for monitor. Oh, but this stopped working, right? MDT effective DPI. Let's try that. Man, I should have gone breadth first instead of depth first just now. Because if this works, I mean, I guess it was an interesting side quest for the video, but god damn it, I wish things were easy. All right, so we'll do DPI for monitor, which needs I mean, we'll do this a little bit differently, right? So we'll do get. Whoa, what just happened there? Let me just restart. Kanata. Sometimes it gets a little bit funny. Alright. I lost where I was completely. DPI for monitor. Get DPI for monitor. We have a H monitor. We need to pass MDT effective DPI. And we need to pass U32s. Let DPI X equals 0 U32. Yeah, do that. Make these mutable. And give addresses. Right? And that returns a void result. Excellent. So once we get that, we're going to do DPIY. DPIY divided by 96.0 as F32 result. F32. Let's try this. And we need to ref this. Okay. So let's call this DPI for monitor. DPI for monitor, and let's see how this goes. If it's this simple, man. I mean, this is not simple. That's one of the deceptive things about simplicity. If something is truly simple, it should be very easy to arrive at. Oh my god, it worked. Thank heavens, it actually worked. Alright, let's set DPI to 100. So the thing is about, even though something is simple, right? Like, it should be, I think discoverability is a part of simplicity, right? So like, this code, DPI for monitor, like, great. Why isn't it easy to find? Oh yeah, this is so much better, dude. That's awesome. Alright, let's switch this back. And clean this up a little, right? So let's see what Bacon is yelling at us about. So we actually have some dead code now. Yeah, this can go. Get rid of some imports, no doubt. Unused imports everywhere. Mm, 807. I'm not using that anymore. 69 and this one too. 1325. Oh, 1325. So we'll call this monitors have same DPI, right? Because now we're actually calling the DPI function DPI A, DPI B. Sweet. Oh, that feels much better. Doesn't that feel so much better? That feels amazing. These clippy links, on the other hand, do not feel so amazing. Let's see if we can do F32 from try from? Can we try from? We cannot try from. Okay, I guess we live with it. I guess we just live with it. Allow clippy cast precision loss. Consider comparing them within some margin of error. Okay, well, I will just do this. F32 epsilon. Oh my god, that felt like an absolute age. I feel like I aged a year in an hour. But we are done. We are done. I'm very happy. Because this was annoying me so much as well, and I'm glad that it just works now. Sad that it took me so long to get to this point, but you know, hopefully if you're watching because you're interested in this kind of Win32 development, you also learned something. Just do DPI Y divided by 96.0. All right, my friends, let's head on over to the sponsor page and say thank you to the lovely sponsors. Private sponsor number 1, 2, and 3. Thank y'all so much. Thank you also to Julian, Evan, Maxwell, Red Lobster, Darian, Leandro, Alex, Kwang, Surefire, Michael, Pavel, and Hisayuki. My friends, you are all awesome, and thank you so much for your support, for your ongoing support in most cases. If you too would like to become a sponsor, head on over to the sponsor page. You can be either a one-time sponsor, you can be a monthly sponsor, and you can sponsor for just $1 a month if you would like. I mean, that is the minimum that I have to put on GitHub sponsors. I guess it's a payment processing thing, but really, even $1 a month, $1 one time, it means a great deal to me, and I appreciate it so very much. However, if you are not in a position to become a sponsor, the very next best thing that you can do is hit subscribe on the YouTube channel where I'm guessing you're watching this video right now. So at the end of last year, we finally made it to 1,000 subscribers. Amazing, thank you all so much. And the next milestone that we are looking to hit I can actually show you this time since I'm logged in. Where is it? So, oh, I don't know if I want to do this just yet. All right. But basically we are like not very far away from getting monetized in terms of ad revenue. And that means that all of the ads that you see popping up on the tutorial videos, on the live streaming videos, finally, you know, the project will start getting a cut of those. So I think it's 500 watch hours left. So, you know, if you like watching other people code in the background with chill vibes and chill music while you do stuff, please do go ahead, leave some of the playlists on in the background while you do stuff. Alright my friends, that is it for today. Let's head back to the main page. I hope that whatever you all do today, you have a great day. Free Palestine, and I'll see you all back here next time.